All right, let's get started. We're finishing week 6, which means we have an in-class today, right? And we have, today is all about Poisson, Poisson, Poisson. This manual equation, this Excel equation, and the table. We're going to learn 3 different ways to do Poisson. As far as the schedule is concerned, today is the 14th, we're finishing week 6. Thursday we start week 7. The following week, Tuesday, we end week 7. Thursday we start week 8, then a week off for spring break. When we come back from spring break that Tuesday, we finish week 8. Thursday is quiz 2. All right, that week we come back. So just keeping you up to date what's going on. So here's week 6 again. There's only 2 assignments, a written assignment and Excel assignment. The written assignment has these first 3 problems, which are very much Poisson related. Then number 4, though, is not Poisson. Instead, it's about those counting rules. You have to determine whether you're going to use combination or permutation on these 2 problems. Okay? Then the Excel has, what does it have? 1, 2, 3, 4, 5 Excel equations in these 5 boxes here. And it's pretty obvious you're going to use Poisson for all 5 of them. Just a matter of knowing. I tell you what, if you do this right after class, or even while the lecture's going on, while it's fresh in your mind, you're going to find these so easy. But if you wait 2 days, you're going to be racking your brain trying to remember exactly which direction everything goes in on here. Because what's hard about Poisson when it comes to Excel, it's kind of like the binomial distribution. That whole thing, when do you use the 1 minus, when do you use the opposite of what you're supposed to for the first number, that whole confusion takes place with Poisson also. So there's the warning. Where do we start here? Let's start with the in-class assignment. Go ahead. Just kidding, it never gets old. All right, hang in. Poisson. Poisson, Poisson, Poisson. Here's the deal. This is used with discrete data, not continuous data. So the numbers you're going to be asked about are always going to be like a 1, a 2, a 3, 4, no 1.2 or 3.5. All right, so there's Poisson. It's always about the number of occurrences over an interval of time or space. The key word there is the question is asking you about the number of occurrences. So I want to read some examples. I'm going to turn it into a question. It says the number of knot holes in a 14 linear feet. The question may say, what's the probability there'll be 5 knot holes in 14 linear feet of this pine board? What's the problem? I'm asking you how many knot holes, that's the occurrence. The interval is the 14 linear feet of pine board. Next one says the number of vehicles arriving at a toll booth. The question might say, what's the probability there'll be 5 vehicles arriving at this toll booth in the next 1 hour? That's how you recognize Poisson. It's asking you how many of something over an interval, time or space of some kind. The first one is the number of knot holes in 14 linear feet, so I want to turn it into a Poisson question. I don't remember how many I asked, but I'm going to make up a new one and test this. I can't remember. What's the probability there are, how many did I say? What's the knot holes in 14 linear feet? Nobody had it written down? Okay. What's the number there'll be 6 knot holes in the next 14 linear feet of this pine board? The question was, knot holes is the occurrence. We're counting the knot holes, but the interval is 14 linear feet of this pine board. That's the interval. So that's how you recognize Poisson. It's always asking about the number of occurrences over the interval. Now, in a few weeks after quiz 2, or is it after or before quiz 2? I can't remember. We're going to talk about exponential probabilities. And the number 1 confusion is mixing up exponential with Poisson. So I'm going to go real heavy into it because they almost look exactly alike. The only difference is exponential flips these. It asks about time or space. It asks about the interval between the occurrences. So it might say, what's the probability there'll be 14 linear feet between the next 2 knot holes? That question was asking about the interval of 14 feet between the occurrences of knot holes. That's exponential. We're learning that later. Today is all about a question that's asking you for the probability of the occurrences over an interval. Let me do that toll booth again, ready? It says 1 hour, but I'm just gonna say it a different way. What's the probability there'll be 20 vehicles arriving at this toll booth in the next 60 minutes? That's Poisson. The occurrence is the vehicles arriving at the toll booth. The interval is 60 minutes, an hour. That's how you recognize it. And you cannot let any part of the problem influence you, especially how the average or means described, you deciding, should I be using the Poisson or should I use exponential? Don't let that influence you. You have to focus in on the question that says, what's the probability of? That's the part where you make a decision. Should I be using Poisson or should I use exponential? Go ahead.
Will I ever ask for like a range of time? So like instead of 1 hour, would it be like from the next hour to 3 hours?
No, it won't be a range of time. It will be a specific. It will be a specific interval of some kind. But the bad news is, many of these problems will describe the mean as how many in one type of interval. Let's say 1 hour. Let's say the mean says, I'm doing the number of vehicles, ready? Usually, on average, we have 20 vehicles per hour at this toll booth. What's the probability there'll be 10 vehicles in the next 30 minutes? Now, here's the deal. The mean was described as a certain amount of vehicles over an interval of an hour. But the question was asking about a certain amount of vehicles over a different interval, which was a half hour. And if you recall from last Thursday's lecture, I said, this is where you had to recognize that you never change the question. You never change the number in the question that you're being asked the probability of. If you recognize the interval is different than the mean, it's the mean you convert. Everybody hear that? I want to say that again. You never change the number in the question, but if it's a different interval, you got to go and convert the mean in the story to match the interval in the question. That's the conversion that takes place. And we're about to see an example of that here. Okay, there's our formula. I put it in words up here though. That mu symbol, I put the word mean to the exponent of x. X is whatever you're being asked the probability of. That's what x is. Then it's being multiplied by e. We said e is always 2.71828. Right? We're all using 2.71828, and someone may round this to a 3, but we're using at least 4 digits to the right of the decimal. And then it's to the power of the mean negative. So that's an exponent to e. And it's got to be a negative exponent over x factorial, whatever you're being asked about, however many you're being asked to find the probability of, factorial. There's the manual formula. Here is the Excel formula. Equals Poisson, parentheses. The first number in the parentheses is the x, the same x over here. Whatever you're being asked to find the probability of. What's the probability of? That number is your x. The second number after the comma is the mean. The converted mean if you have to convert it. Remember that. Same with the manual. That mean in this formula here is what you converted it to if it needs converting. That's the mean you use in both of these. Now, here's the weird part. Like binomial distribution, you could either use a 1 or a 0 on the end. Here's the deal with Poisson, like binomial. You could be asked the probability of exactly, hey, what's the probability there'll be exactly 3 cars coming up to this toll booth in the next 30 minutes? Or you could be asked 3 or more cars, 3 or less cars. You got the more than, the less than, and the exact. If you're ever being asked the exact, that's a 0. But if you're being asked the less than or the more than included, more than just one number, that's a 1 on the end. And then you got to decide whether you're going to use a 1 minus in front or not. When would you put the 1 minus in front? When the question has the what? Less than or more than?
More.
More than, you got it. But add this little notation. If it is a more than, and you're going to use the 1 minus in front, that first number has to be the opposite of what you're looking to find the probability of. The opposite, just like binomial, that same weird rule on that first number is for Poisson also. Okay, you heard all the rules. want to show you one more thing. We're gonna solve each one of these problems 3 different ways: manually, Excel, and then this. This is almost too easy. You won't have a problem on your quiz where I'm going to ask you to use this table to solve it. It's too easy. But you could use it to check your answers. I'd have it in front of me. Let me make it bigger so we can see it. How you use it is, you got to go across the top and find the mean. Whatever that mean is, that middle number here, that number in the numerator here and here, whatever that mean is across the top. But look, if it's greater than 1, you got to go down to the next row. There it is. This one goes up to 2. This one goes up to 3, up to 4, up to 5. So there's the mean. But then x has to be 0 through something, 7 or whatever. X is in the left. You got to match up the mean with the x, and then you just find where they intersect. But here's the deal. If I was asking, let's say the mean was 0.1. Let's say 1. Let's say the mean is 1, but it's asking for the probability of 2. So here's the mean of 1. Let me go down to 2. There's the probability. What does it say? 0.1839, right? Now, what if it said, though, 2 or less? You got to add the 0.1839 plus the 0.3679 for the 1, and then go up to 0, 0.3679. You got to add all 3 of those together for 1 or less if you're using the table. What if this were for 2 or more? Well, you could add 2 plus 3, all these for representing x for 2 or more, or just add 1 or less and subtract it from 100%. Subtract it from 1. This will make sense. We're going to use all 3 of these as we go through the problem. Let's start with this problem right here. I'm just doing the top first one. Patients arrived. Now, this should look familiar. We talked about this on Thursday a little bit. Patients arrived at this emergency room at Mercy Hospital at an average rate of 6 per hour on weekend evenings. 6 per hour. There it is. There's our mean. There's the average. What's the probability of 5 arrivals in the next 60 minutes? Do I need to convert the mean? Yes or no? No. Leslie says no because?
Per hour.
That's right, exactly. he couldn't hold himself back.
Sorry.
That's right, because they're both an hour. Even though one says 60 minutes and one says an hour, they're both an hour. So there's no reason to convert the mean. The 2 numbers we're going to use, where's my pen? What the heck? Here's my pen. Is 5 and 6. So 6 is our mean, 5 is the question. I'm going to set this up. This is going to be, matter of fact, I'm setting it up right here. What's the mean? 6. 6 is the mean to the power of x, asking about 5, times e, 2 point, gotta look again, 712, 71828, 71828, to the power of negative mean, to the power of negative 6. So there's those 2, 5 factorial. There it is. Again, the mean was 6, because it says the average rate of 6 per hour. There it is, the average is 6. The question's about 5. 5 or less or 5 or more? It says, what's the probability of 5 arrivals? It doesn't say or less or more. This is exactly 5. And there's the setup. The mean is 6, x is 5, there's e, there's the 6 again, there's the 5. Here's the math. 6 to the power of 5, 7,776. E to the power of negative 6, 0.002479. 5 factorial, the denominator is 120. Now, this is the work I expect to see on your quiz too. Just like I'm doing, I broke this down. Then I took these 2 numerators and multiplied them and got 19.2767. Oh, I didn't finish it though, did I? Hang on. Yeah, let me get my calculator out. Did I make a mistake? Anybody? 19.2767. Here we go. 19.2767. Divided by 120. Is that correct? 120. So the answer, the probability of 5 arrivals during an hour, when we usually have 6 arrivals, to have exactly 5 is about 16%. 0.1606. barely over 16% chance of us having 5 patients. Okay, help me with Excel. Here's the parentheses. What's the first number?
5,
Very good. What's the second number?
6,
Very good. What's the last number? 0 it is. That's it. Let's do it. Let's see if we get the same answer.
Professor,
Equals.
is it always 0 at the end?
I'm sorry?
Is it always 0 at the end?
No, only if it's asking for exactly the probability of a number, like this one is. If it's 5 or less or 5 or more, you've got to put a 1 on the end. So you could use Poisson dot distribution or just the old-fashioned Poisson. I just use that one. Here we go. X is 5, comma, the mean is 6, comma. I'm putting a 0 on the end because it's asking for the probability of 5 only, not 5 or more or 5 or less. We should get, if we did it right, 16 point, well, just a little over 16%. What'd I do? I got 2 parentheses there. Hang on. Yeah, get rid of one of these. There we go. 0.1606. Same exact answer. Go ahead.
So, say it was like 5 or more.
You ready?
More than 5. Would it be 1 minus Poisson 5, 6, 1?
No. He's saying, what if it were 5 or more? How would this change? It would be equals 1 minus. You did say that correct. You are correct. The only thing that changes is that first number. Because 5 or more, the opposite would be 4. And I think you said a
1 more is
5.
1 minus?
So 4, the opposite of the 5, because 5 or more. You gotta do 4 or less. And then a 1 on the end. 1 bias in the front, the 4 there, and the 1 will be the changes. Okay, let's do another one. Oh wait, we gotta use the table. We're gonna use the table now. Our mean is 6, and we're trying to find the probability of 5. So here I go to the table, I go across the top, try to find 6. So this only goes to 1, that one goes to 2, that one goes to 3. I go all the way down here, there's my 6. And then I gotta go down to where 6 and 5 intersect. So right here's 5, take it all the way across. Look at the answer right next to my pointer, 0.1606. Boy, that's almost too easy. We solved it all 3 ways now. Manual, Excel, and this table, which has been posted for all of you to download so you have it.
Can we just use a tripod?
No, we can't. No, we gotta show you. The question is either gonna ask you to solve it manually or it's gonna ask you to solve it using Excel, showing all your work. It will never ask you to solve it using the table, just so you know. All right, let's do the next one.
Can we do it again on the table?
Can we do what on the table?
Can you do it again on the table?
Do what?
Can we do it again on the table?
Show 'em how to do it.
Show me how to do it.
You wanna do it again? This one we
Please.
just did?
Yeah, on the table only.
Okay, I'm gonna do every one of them on the table though. Can I just go to the next one?
Okay, yeah,
Okay.
sure.
What's the probability now of 4 arrivals in 30 minutes? We're doing the second one down. What's the probability of 4 arrivals in 30 minutes? I'm gonna do this one right here. What is, well, first of all, X is what? 4. You got that. X is 4. So where's our X go? Goes right here. There's gonna be a little 4 right there. And then it also goes down here. 4 factorial. Well, I didn't leave enough room here. I'll have to erase that. Okay, now what's our mean?
3.
Who said that? Very good. You know what he did, right? The means described, we did this already last week, so the means described is 6 per hour, but the question says what's the probability of 4 in 30 minutes? You have to convert the mean to 30 minutes. Since the mean's at 6 per hour, 30 minutes is half of 60 minutes, so you gotta convert the mean from 6 to half of it, which would be a 3. So that's why this is, this is 3 to the power of 4, and E 2.71828 to the power of -3, the negative mean. This happens to turn into 3 to the power of 4 is 81. E to the power of -3 is 0.049787 right up here. And then 4 factorial, 4 times 3 times 2 times 1 is 24. I multiplied my numerators and got 4.0328 divided by 24. Let's figure out the answer to this one. Let me get my calculator. 4.03.032 2747 divided by 24 equals, so manually we get a little over 16.5%, like 0.1680 equals 0.1680. There it is. Help me now, we're gonna do Excel. Let me get this off here. We're doing Excel, and it says, what's the probability of 4 arrivals in 30 minutes? What is the first number in the parentheses? What's the probability of 4 arrivals in 30 minutes? What's the first number in parentheses?
4.
4, comma, what's the mean? 3, very good. What's the last number?
0.
0 it is, because it's not asking for 4 arrivals or more. It's not asking for 4 or less arrivals. It just says 4. There's your answer right there, 4, 3, comma, 0. Let's do it. Let's see if we get the same answer, same result. Here we go. I'm changing these numbers now to be a 4, a 3, and a 0. If this turns out right, we should be a 0.1680. There it is, 0.168031. Go ahead.
I'm confused how you get the 3.
Okay, the 3 again, let me go back to the story so you can see it on the PowerPoint. Right here, the mean is being described as, says the hospital at the average rate of 6 per hour. But that's for 60 minutes. The question says, what's the probability of 4 arrivals in 30 minutes? So you never convert the question, 4 arrivals in 30 minutes. You gotta say, well, if there's 6 on average in 60 minutes, and 30 minutes is half of 60 minutes, then use half of the average. Instead of 6, use a 3.
Okay.
All right, we're gonna see another one where you gotta convert it, so you're gonna see it a couple more times. Real quick now, Lauer, is he there? We're gonna do the table. You ready? You're gonna help me through.
Mhm.
What should I be looking for the, which row at the top should I look for? What's my mean?
My mean is 3.
3 it is. So we gotta go up here to 3. There's 3 right here, this last column here, and then what's the X?
4. What is the X?
4. Go down to 4. Right next to my pointer, to the left of my pointer, 0.1680. Same thing we got manually, same thing we got using Poisson. Go ahead.
So the table only works if it's the exact number?
No, well, here's the thing. You ready? If this said, what's the probability of 4 or less for the table, we would add all the percentages from 6.1680 up, add them all together. So 0.1680 plus 0.2240 plus 0.2240 plus 0.1494 plus 0.0498 will give you the probability for 4 or less. So it takes a little time using the table. But with Excel for 4 or less, you guys ready? This is it. 1 minus, this is for 4 or less. What's the first number? What's that first number? For 4 or less.
Or more?
4 or
Oh,
less.
I'm sorry, 4 or more. 4 or more. 4 or more?
3.
3. What's the mean?
3.
1.
1.
What 4? This would be for 4 or more. Sorry, I was saying 4 or less. This is already 4 or less. It's just changing that to a 1. Go ahead.
You said imagine it was 4 or less, you said the same thing. We would count whatever the number is and whatever's
Less.
above it.
Yeah.
That's
now, if
less.
it's 4 or
For
more,
below
you can
it.
count below, but that's a lot more counting. You can
Yeah.
count 4 or less and then subtract it from 1.
Yeah.
The opposite of 4 or you could do it that way.
If it's 4 or more, do we lose that number?
I'm sorry, say that again?
If it's 4 or more, do we lose the X?
You would if you're using the table. Yeah, if you're using the table for 4 or more, you'd have to count 4, 5, 6, 7 if you want to do it that way, yes.
4 or less.
Yep. But using Poisson is where you use the opposite because of this 1 minus in front. All right, hang on, let's do another one. If you have the new edition, it'd be page 184 from the book. I took a picture though.
If it was 5 or more.
Let me zoom in.
If it was 6 or more, you put no or less. If it's or less, the same thing.
What's this? What page is this? I can't remember. Yeah, this is it. Here we go, over here.
Zero is this one.
Let me zoom more.
No, this is equal.
Okay, so we're gonna try this right here. We can now address questions first posed by Ann Jones in an introductory case in this chapter.
Professor?
Recall that Ann's concern about staffing needs for the Starbucks that she manages.
Professor?
Go ahead.
I have a question about that one again.
Which one?
Right there,
Why did you change up the numbers for or more?
This one is
Yeah.
or more right here.
Yeah. Why did
Change
you
that first number because it's subtracted from 100%, so you gotta have the opposite of 4 or more, which would be 3 or less. You gotta have the opposite, just like binomial was that way. Binomial, anytime we're using the one minus in front, you had to have the opposite for that first number. Same exact way.
The
with
number
this one.
below it, right?
The number below it. That's right. Okay, here's another example. And it says, the Starbucks that she manages, is it scheduling? Staffing needs. She has specific questions about the probability distribution of customer arrivals at the store. So how many customers are arriving? And believes that the typical Starbucks customer averages 18 visits at a store in 30 days. So the average customer visits on average 18 visits in 30 days. Everybody hear that? It says how many visits would Ann expect, meaning the average, in a 5-day period? Now think about that. Let me repeat it. This is changing the mean. We're converting the mean. If usually there's 18 visits in 30 days, how many should be expected in 5 days? How do you convert 30 days to 5 days? Divided by? 6. So 18 divided by 6 equals? 3. What is that, 5 days? Here's 5 days. Ready? 3. All right, keep going. 15 days. 18, typical customer visits the Starbucks 18 times in 30 days. What if you had to convert the mean to 15 days?
9.
9, because 15 days is half of 30, so half of 18 is 9. 60 days. Typical Starbucks customer visits 18 times in 30 days, but you need to convert to 60 days because of the question. What would be the mean then?
36.
36. There it is. 60 days is twice as much as 30 days, so twice 18 times 2 is 36. 10 days. The
Six.
question's all about 10 days. But all we know is there's 18 customers per 30 days. What should you expect, or what would be the mean then for 10 days?
6.
6. 10 is a third of 30, so a third of 18 would be 6. That's how you convert the mean. It's all about when you read the question, you look back at the mean, you say, does it need converting based on the interval being asked about in the question? You don't change the x. Whatever is being asked about, you leave that number the way it is. You have to convert the mean. That's where the conversion takes place. This is the same for exponential in a few weeks, so that's why I want to make sure you're getting this. Exponential explains the mean sometimes in the exact same way Poisson does. And the most common mistake that will kill your grade on quiz 2 or the exam even, is that you interpreted a question as being exponential and you're solving it using the exponential formula when all along it was Poisson. It's just so hard to give you partial credit because you don't even have it set up right. That's where most of the points are because you're using the wrong equation. So we're really gonna focus on, when I get to exponential, on having you guys focus on reading the questions and being able to say, okay, that's exponential, okay, that's Poisson, oh, that's binomial, that's uniform, that's normal. That's the key. That's how you protect yourself from losing a ton of points on the exam and killing your grade. It's all about focusing on recognizing which problem you have. Then you set it up, that's most of the points. There's no way you're not passing the exam if you know what you're recognizing and set it up. Don't get me wrong, there's someone right now that this will happen to, because I haven't had a semester where it hadn't happened to someone yet. It's gonna happen, but I'm gonna say it 100 times to try to stop it from happening. I want you to pull through without doing that same mistake. B, here's a full question now. We have to determine which one of these means we're gonna use based on the question. What's the probability a customer visits a chain 5 times in 5 days? 5 times in 5 days, what's X? 5, what's the mean? I can't hear you. 3 it is, because it's being asked about 5 days. We converted 18 and 30 days to 3 and 5 days. So it's the mean, 3 to the power of the question, which is 5, times 2.71828 to the power of -1. Come on. That's right, because it's the mean. It's the mean over 5 factorial. The question's about 5. There it is. There's most of the points right there. There's no way you're gonna fail that exam if you could just set that up. Don't get me wrong, there's more points to get, but here's most of them right there. You recognize the number, you converted the mean, you put them in the right place.
So you don't care if you show E or the 2.7?
I mean, I want you to show E, yeah, what do you mean?
On paper, you don't, so you wanna mark simultaneous with E?
You mean if you just put an E there instead of 2.71828?
Yeah.
I guess that's okay, but you still gotta show me the next number it turns into.
How many, up to how many decimal points? Up to how many decimal points do you want?
Oh, I want you to go at least 4 on every number. Always go, the rule is to go 4 digits to the right of every decimal number you have a decimal involved.
So on my calculator, I can just put E in there. What,
Yeah.
What do you want me to show my work for?
When you take E and put it to the negative number, write that number on your test, just like that.
Oh, so the E to the -3.
Yeah, you want me to show you how to do it real quick? Just to.
Like-
E is always got a key right there on this one, right there, E. So there's E, 2.71828, 1828, 459, blah, 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 blah. Now, to the power of, so I'm hitting my X to the power of Y. I'm gonna put it to the power of 3, but you've gotta turn that into a negative before you hit equals. So I'm gonna turn it into a negative, then hit equals, and I should get, this part right here is gonna be 0.049, 0.04979. There, I went 5 digits. Did we already use this one? There it is. No, that's not, is that the same one? No, that's a different one. Oh, this is. There it is. So we already had this to the -3 right there, and there's the exact same number. At least we're getting the same result.
So it's okay if it's like 0.2 away, or like 0.002 away from the chart?
Yes, I think, I wanna make sure I got that from the chart. Oh, you're gonna use the chart? From the table?
Yeah.
Let's talk about, we're talking about 3 and 5, correct?
I'm talking about 3 and 4.
Using 3 and 4, this one up here?
Yeah.
Okay, let's go ahead and look at the table. You're only using the table to confirm if you got it right or wrong. Here's 4 is the mean, and we're looking for the probability of 3, I think, is that correct? 0.1954? No, I got it backwards, 3 is the mean, sorry. 3 is the mean, so let me go up here, there it is, and now go down to 4, there it is. You're just using the table to confirm that this manual calculation turned out correctly. Or to make sure that your Excel equation turned out correctly. That's all you're using the table for.
So if I round it, I'm gonna be off ever so slightly. Wouldn't that affect that answer?
If you round this, you mean?
So I did.
What did you
mean was
round?
3. My bad. I did mean was 4, X was 3.
Right.
And then at the end of it, I got 0.1952. But on the chart, it's 0.1954. It's not on the board. It's not on the board.
Tell me again, what's your mean then and what's your X?
The mean is 4, X is 3.
Okay, we're going to 4 and 3, which we haven't done yet, have we? 0.1954. It's going 4 digits to the right, but
No, I get you, but when you like write it on paper and then you have to round to decimal points, you're gonna be off by like 0.2, 0.00.
I wouldn't worry about that. No big deal.
Oh, okay, so
No big deal as long as you're rounding correctly. Go ahead.
Poisson distribution, the Poisson distribution, is that a discrete or a continuous? It's a time interval.
Poisson is discrete. Is a discrete calculation. But you're asking about this, aren't you? Or you're asking for the .dist?
No, I'm just, no, by definition.
By definition, it's a discrete probability calculation.
Even though there's an interval, even when there's an interval,
Even when there's what?
interval.
interval.
There's always an interval. I don't understand your question.
Because for
I'm not-
continuous,
No, if the question's about an interval, then it's exponential. That would be continuous data. But these questions this week are all about how many per interval. That's why in Poisson, we're only about discrete data. How many cars pull up to a toll booth? How many cars are in the parking lot? How many cars pass us? It's always gonna be 1, 2, 3, 4, 5. So we're not using the continuous one till we get to exponential. All right, let's do another one. I'm still on page 184. Hang on, I gotta bring that picture back up. Okay, we're going up here to number C. It says, you ready? Don't forget the mean. The mean is 18 per 30 days. That's the mean. Then it says, what's the probability that a customer visits the chain no more than 2 times in 5 days. No more than 2 times in 5 days. If I'm manually calculating this, first of all, no more than, I want you to turn that into words that we use more commonly. Some number or less, some number or more.
2 or less.
There you go. No more than 2 visits means 2 or less. So think about it as 2 or less. Are you ready? What's X?
2,
2. What's the mean? How many days is the interval being asked about?
5,
5 days. So we gotta convert 18 and 30 days to what? 3. The question's about 2 or less, and the mean is 3. 3 to the power of 2 times 2.71828 to the power of -3 over 2 factorial. But because it's 2 or less, we got to do this whole equation again with this being a 1 and that being a 1. Then we got to do this whole equation again with this being a 0 and this being a 0. What's 0 factorial, by the way?
0.
1.
Oh, is that
1. 0 factorial is 1. That's the odd one that we talked about when I taught you guys factorial. That's the weird one. And then you would add the 3 probabilities together. Just like if we were using the table, again, this would be 2 or less with a mean of 3. So we're going up to the 3. 2 is right there, 0.2240. But when we calculate it for 1, there it is, 0.1494. And when we calculate it for 0, 0.0498. We would add those 3 together for 2 or less. Now let's use Excel. Equals POISSON. 2 or less. What's the first number?
2. Oh.
2, comma. What's the mean for the period 5 days?
3.
3. What's the last digit?
0,
1,
One.
because it's 2 or less. If this were asking about 2 and only 2, that's a 0 on the end. But 2 or less, we put a 1 on the end.
Yeah, the same thing, just 1 at the end.
Go ahead. Question.
Same thing every. If you asked us 5 or less, we have to do the calculation 6 times.
Yeah, for 5, for 4, for 3, for 2, for 1, for 0.
0.
My question is, what do you think the odds are of me asking you 5 or less question on a quiz? though?
You're not gonna ask us that.
Exactly.
I just know, yeah.
Probably-
I'm just asking.
Yeah, you would have to do it 5 times.
Yeah. Okay.
Yeah. And when I'm asking for a question, let's say this were 2 or more, and you were doing it manually, you would want to do 1 and 0 and subtract it from 100% instead of having to do this calculation a bunch of times. If you had to do it manually for 2 or more, you would do it twice. You would do it for the opposite of 2 or more, which is 1 and 0. And then you would add the 2 answers together and subtract it from 100% or subtract it from 1. But I'm not even going to ask you to manually do a 2 or more. You are going to have to probably manually solve an exact one though. Like, what's the probability of 2? Or what's the probability of 5? It will be an exact one that you have to manually show me you can set up. Will you be converting the mean? Probably. So you make sure and look at what the interval is being asked about in the question to determine how to, and show your work how you're converting the mean. Are you dividing the mean by 2? Are you dividing it by 3? Are you dividing it by 4? Well, how are you converting it? Or are you doubling it? Look at this. The mean was given to us 18 per 30 days, but if the question's about 60 days, you gotta convert that mean by doubling it. So even that's possible. You gotta show me you took 18 and times 2 and turned it into 36.
And then on that one, if you wanted to solve it by hand, you would do that equation with the,
X.
1 in it, or 1 is 0.
That's right. What he's asking is, again, if the question were 2 or more and the mean is 3, you could manually do this with putting X as a 1 here and a 1 here and solve it. Then put X as a 0 here and a 0 here and solve it. And then add those 2 answers together, subtract it from 1. And that would be for 2 or more, because you found the opposite of 2 or more, 1 or less. And then you subtract it from 1. The opposite of it would be 2 or more. But I don't think I want you to spend a bunch of time manually calculating 2 answers to get the results to add together and subtract from 1, because the amount of time that would take on your quiz, next quiz would be too long. Like I said, you will have a manual one on your quiz, but it's probably going to be asking you for a number exactly. There won't be an or less or an or more, so that you only have to do it once. The Excel part of the question on the quiz, that will probably be an or more or less. Especially, and the part you want to focus on is, where everybody gets confused is, if it's an or more. Because if it's an or more, you gotta put that one minus in front, and you gotta put the opposite as the first number. Just like binomial. That's the hardest part to remember, is having to put that opposite right there. All right, let me look here. We're going now to, oh, right here. Hang on, what is this? Is this it? Yeah, boom. Let me make this bigger. Here we go. Motorists arrive at a gas station at a rate of 2 per minute during the morning hours. Let me get this on here right now. Let me erase some of this. They arrive at 2 per minute. So you go ahead and set this up manually and write the Excel equation. What's the probability that 6 cars will arrive during the 5-minute intervals? Show me if you gotta use conversion. Set it up manually, add the manual equation, and write the Excel equation also. This is during 6 cars it's asking about. No, this is not the in class. No, this is practice. This is us talking. Unless you want to watch the asteroid come through, right about France again. Do that. These are too easy now, aren't they? We've just gone through too many of them. There's no challenge to them now. Manually in Excel, I'm going to get ready to solve it myself. Give you just a couple more minutes. Write an Excel equation. See if you're there. See if you're ready for the quiz.
Is this in class?
Set it up manually.
No, it's not.
Figure out what the mean is. Decide if you need to convert it.
Yeah, I mean, so you times it by 5.
You ready? Motorists arrive at the gas station at a rate of 2 per minute. So here we go. I'm just putting 2 per minute right there. If the question asked for about, what if the question asked about 5 minutes? What if it asked about 2 minutes? What if it asked about 10 minutes? Help me out. 2 per minute. What if that's 5 minutes? What would be the mean?
10.
I hear you. 10. What if it's 2 per minute? What if it's about 2 minutes? What would be the mean?
4.
4. 2 per minute. What if it's about 10 minutes? What would be the mean?
20.
There you go. Whatever's happening to the information you have to turn it into these other intervals, you got to apply it to the original mean to convert it. It's just your basic, like here, 2 over 1 equals x over, I don't know, make you do the 10. Cross multiply, then divide. It's the same thing we're doing in our heads logically. Cross multiply and divide. Okay, so this is asking about a 5-minute interval, which we covered right here. So if you said the mean you're going to use is 10, you got to write. There's the first step. The question is about 6. So x, 6 cars is your x. So now I'm going to do the equation. The mean 10 to the power of 6 times e 2.71828 to the power of negative 10 over 6 factorial. If that's how you set it up using 6 and 10, you did it correctly. Ton of points right there. That's how you set it up. Now, I'm about to do the Excel. Does everybody have an Excel equation ready to go? Equals Poisson, something, something, something. Ahmed, you ready? Ahmed, you ready?
Are we gonna calculate it?
You ready? Poisson, tell me the first number. What's the first number after the parentheses? 6 it is. He's saying 6 is your x. Very good. Comma, what's the second number?
10.
10, because that's your mean. That is correct. What's the third number?
0.
0 it is. You're absolutely right. That's finding the probability of 6 when the mean is 10. We got the mean because it says 2 per minute, but the question's about 5 minutes, so we had to convert it to 10. That's the key. This is too easy. Is this too easy? What did you say? What do you mean, no? I'm running out of examples, you guys. Let me look. Oh, okay. Here we go. Now we're going to do this for, I just want to change the Poisson I want it instead to say, instead of 6 cars in 5 minutes, 6 or less. Help me out, 6 or less. What am I changing? 6 or less.
No, just we're changing the zero. One.
That's it, just that. 6 or less, there it is. 6 or less. Here we go. 6 or more.
1
6
minus.
more, hang on, here, 1 minus here.
1 minus and then 5 instead of 6.
Oh, this is becoming too easy. 6 or more, 6 or more, the opposite is the 5 and the 1 minus in front. 6 or more.
Huh?
Boy, this is almost too easy now, isn't it? Hang on. I'm not even I was gonna bring up the table, but why? Why bring up the table? You gotta add all the percentages together for 6 or more, or 6 or less. You'd have to add a bunch of numbers together. Now, I wanna give you a hint. There is another Poisson table out there that instead of giving you the individual numbers, like this, whoops, instead of giving you these individual probabilities, it gives you the probability from each number or less. So right there where the 4 is, let's say your mean is 3 and your x is 4, instead of that being 0.1680, it would be all of the ones from 4 and below added together. It would give you the probability for 4 or less on a table. So I do want to let you know that table does exist out there for any number or less. All right, that's all the examples I have. So I'm ready to do the in-class.